There's this romantic idea we all have of the lonely genius, the one person in a garage or a lab who just cracks the code.
Right, the singular mind.
Exactly. And for the last decade, that's really felt like the driving force in AI. The race was to build one single monolithic brain that could do everything.
The God model.
The God model. But I've been reading this new paper, and it's making me wonder if we've sort of hit a wall with that whole approach. It's asking a really interesting question. What if the future of AI isn't a bigger brain, but a better meeting room?
It's a classic shift, isn't it? Moving from just scaling one thing up to getting lots of smaller things to work together smartly.
So what are we looking at today?
The paper is called MoCo, a one-stop shop for model collaboration research. It just came out late January 2026. It's led by Shangmin Fang, but get this, there are 20 authors on it.
20 authors. That's kind of perfect, isn't it? A huge team of people writing a paper about teamwork for machines.
The irony was not lost on me, yeah.
But let's be real for a second. Why do we even need this? Because from the outside, it seems like the big models, the GPTs of the world, they seem to be doing pretty well on their own.
They are doing well, but well is maybe not good enough anymore. The paper points out a few big problems. First, it's getting insanely expensive to train one of these giant models. We're talking hundreds of millions of dollars.
Okay.
And second, they have blind spots. A model can be a genius at writing code, but then, I don't know, completely make stuff up when you ask about 18th century poetry.
And the old fix was just, well, feed it more poetry.
Right, but that gets clunky. So the whole field has been shifting kind of quietly towards this idea of model collaboration. You have a team of specialists instead of one big generalist. But, and this is the key point the authors make, the research was a complete mess.
Disparate and disconnected. That was the phrase they used.
It's a great phrase. It's like a construction site where everyone have their own set of blueprints. You have one team over here working on one method, another team somewhere else working on another, but they aren't using the same tests, the same benchmarks.
So you can't compare them?
You can't even tell if they're solving the same problem, and that's the gap MoCo is trying to fill. They didn't just write about it, they actually built the thing. MoCo is a Python library, a toolkit designed to be the standard arena for all these different collaborative methods.
When you say toolkit, I looked into it. This is not some small side project. They've packed in 26 different collaboration methods.
Which is huge. Yeah.
And 25 different evaluation data sets.
And that might be the most important part.
Really? Why?
Well, because if you're testing teamwork, you need to test it on different kinds of problems, right? You need a math test, a coding test, a reasoning test, even a safety test to see if the team is, less likely to say something toxic. MoCo puts all those tests under one roof. So now, finally, you can actually compare apples to apples.
Okay, so MoCo is the standardized playground. Let's talk about the different games you can play in it. The paper breaks down how models collaborate, and I want to dig into these because they feel very different.
They are. They operate at completely different levels of the system.
The first one they list is routing. To me, that sounds like a traffic cop.
That's a great way to put it, yeah. The technical term you'll hear is mixture of experts, or MOE.
Break that down for me. What's it doing?
So imagine a question comes in. The router is a small, fast model whose only job is to look at that question and figure out what it's about. It says, this is a math problem. And it sends that question only to the expert models that are good at math.
So it's not waking up the whole brain every single time?
Exactly. You only use the parts you need. It's called conditional computation. It saves a massive amount of energy, and it's much faster.
Okay, that makes sense. The next one is text exchange. This one feels more human. Are they literally just like reading each other's work?
That's pretty much it, yeah. This is collaboration at the output level. Think of it like a writer's room. One model writes a draft. A second model, who's been told to be a critic, reads it and gives feedback. This part's weak, or you should double check that fact.
And then the first one revises it.
Or a third model acts as an editor and combines the two. This is really good for complex reasoning tasks because it forces the AI to check its own work. It's like peer pressure for bots.
But that's got to be slow, right? All that back and forth.
It is. Latency is the big trade-off there, for sure.
Okay, hold that thought. Let's go a level deeper. Logit exchange. Now, I know logits have to do with probabilities, but how do you share a probability?
This is where it gets really cool, I think. So when a model is about to pick the next word in a sentence, it's not just thinking of one word. It has a whole list of possibilities, each with a probability score.
Like a ranked list of choices.
Exactly. It might be 80% sure the next word is apple, but also 10% sure it's pear, and so on. Normally, you only see the winner. With Logit Exchange, the models share their entire ranked lists with each other before a final decision is made.
So one model says, I'm leaning heavily towards Apple, and another could say, whoa, wait, my list says banana is a strong contender here.
Precisely. And then the system can average those probabilities. It's a form of ensembling. It makes the final decision much more robust because it smooths out the weird biases of any single model.
That sounds super useful for things where you need to be really sure, like fact-checking.
It's one of the strongest methods for that, yeah.
Okay, then there's the final level, model parameters. This sounds dangerous, like you're actually performing brain surgery and merging the models themselves.
That is basically what's happening. It's the frontier, really. People call it model merging. You're not just letting them chat, you are mathematically combining their neural networks.
How does that even work? If I try to merge a map of London with a map of New York, I just get a mess.
That is the perfect analogy for the risk involved. If you do it wrong, you get what's called interference, and the model just outputs gibberish. But with the right techniques, the ones MoCo helps you test, you can actually do it.
So you could, take the math part of one model and the French language part of another and smush them together.
And get a single new model that's good at doing math and French. And the amazing part is, you do it without any new training. It's just a mathematical operation on the existing weights.
Wow. Okay, so we have these methods: delegating, debating, voting, and merging. MoCo ran all of them through this standardized test.
Yeah.
So what was the verdict? Does the teamwork actually make the dream work?
The big headline number is the win rate. In their experiments, the collaboration strategies beat the single models in 61% of the tests.
61%. Okay, so that's a majority, but it's not, a total knockout.
No, it isn't, and it shouldn't be. But what's really important is the size of the win when it does win. The best methods saw performance boosts of up to 25.8%.
25%. In AI, people kill for a 1 or 2% gain. That's a massive number.
It's a huge deal. It basically proves that this whole idea of collective intelligence really has legs.
But let's go back to that 39% where it didn't win.
Yeah.
You mentioned latency earlier. As a user, I don't want to wait a minute for my chatbot to hold a committee meeting.
And you shouldn't have to. That's the core trade-off. The paper is very clear about this. Collaboration is not free. In fact, some methods are way more expensive.
Like the debate club?
The debate club is a perfect example. You're generating way more text, so you're spending more time and more compute. If you're just asking, what's the capital of France? Using a collaborative debate is total overkill.
It's like calling a board meeting to decide on the brand of coffee.
Exactly. The paper shows that collaboration really pays off on problems where single models get stuck. Complex logic, multi-step reasoning, tricky safety situations. For simple stuff, a single model is still faster and cheaper.
So that router we talked about at the beginning is maybe the most important part. It has to be smart enough to know when not to collaborate.
Yes. The ultimate system knows when to work as a team and when to let an individual just handle it. MoCo lets you benchmark that exact trade-off. You can plot accuracy versus cost and find that perfect sweet spot.
I want to zoom out a little to the bigger picture here. The authors aren't just dropping a code library on the world. They seem to have a vision for how AI should be built. They use words like open, modular, decentralized.
This is almost the political argument of the pager. Right now, AI is super centralized. You have a handful of big companies that own the keys to the kingdom.
The black box providers.
Right. MoCo is a toolkit for a different future, a modular one.
Yeah.
Imagine an open market where a small team could build a really good medical diagnosis expert model and just plug it into a global network.
So I don't have to build an entire AI brain. I can just build one really good lobe.
Exactly. And if your lobe is the best, the system will route work to you. It kind of democratizes the whole field. You don't need $1 billion to build a giant model to compete. You just need to be really good at solving one specific problem.
That sounds amazing, but is that a realistic future or just, wishful thinking from academia?
Well, a tool like MoCo makes it much more realistic. Before, if you wanted to build one of these systems, you had to invent everything yourself. MoCo gives everyone the same set of tools, the same plumbing. It's like standardizing internet protocols. Once everyone agreed on how networks should talk, the web exploded. MoCo wants to be that standard for how models talk.
A bold goal. But I guess if the performance is there, the incentive is there.
That 25% boost is a very big incentive.
So if someone's listening to this, maybe a developer or a researcher, What's the immediate action item? What should they do with MoCo?
The first thing is stop building things in a vacuum. If you think you've come up with a better way to merge models, great. Now use MoCo to test it against the other 26 methods on the standard datasets. Prove it.
Use the common yardstick.
Use the yardstick. And for everyone else, just start thinking in a more modular way. Are you trying to force one giant model to do everything? Or could you break your problem down and give each piece to a smaller, cheaper, specialized model? This paper proves that the second approach is often the smarter way to go.
It's funny, we started this whole conversation talking about the lonely genius, and everything in this paper, the 20 authors, the teamwork, the 25 boosts from collaboration, it all suggests that the lonely genius model is, well, it's kind of obsolete.
Or at least it's inefficient.
Which leads me to this final thought. We spend so much time in our own lives, in our companies, trying to find that one 10x engineer or that one superstar CEO who's supposed to have all the answers. We build everything around this idea of the monolithic expert.
Vertical scaling of people,
Yeah,
right?
right. But we just went through how the most advanced thinking machines on the planet perform significantly better when specialized agents collaborate effectively.
It really makes you question our org charts, doesn't it?
It does. If the machines are learning that better routing systems beat bigger brains, maybe we should pay attention. Are we building our teams to actually route problems to the right expert? Or are we just yelling at the smartest person in the room and hoping for the best?
And are we creating that safe space for, the Logit exchange, where people can share their uncertainties instead of just pretending they have the one right answer?
That's it right there.
Yeah.
Maybe the future isn't about having all the answers yourself. Maybe it's about getting better at asking and knowing how to listen.
Well said.
Thanks for listening to The Deep Dive. We'll see you next time.